Welcome back to Balvigan Bharti with your mentor Avila Sarkar. In this chapter, I will start with problem number 18 in binomial series, and the problem that will come is uh, yes 18. The term without x in the x function. The term without x in the expansion 2x minus 1 by 2x square whole power of 12. Now there are options, but as I said, I will not go with the option, rather I will solve directly. So as it is without x, so let us assume the term without x be r plus 1th term. So as per the rule, the r plus 1th term of any series can be written as n, the highest power n, c r first term whole to the power n minus r into second term whole to the power r. Okay, now I will separate out all the constant part and only the x part I will keep aside. So this will 2 to the power 12 minus r minus half whole to the power r, and the x will be 12 minus r there, and this x2r that is coming in the denominator, when we will move off, it will change its sign, as from the denominator when it is rising up to the numerator, the sign of the power changes. So that will be adjusted with this, as both having x power of something, so that can be added or subtracted as per the rule of the algebra. Okay, the power is in adjusted like that. So as I know that this term which I have assumed to be r plus 1 having no without x, that means when it being without x, so x power 0 will be the case, because only then x will be abolished or can be removed from this term where x power is getting 0. So x power 0 is 1. So I can equalize this power equal to 0. So then r is equal to how much? It is 4. So once you get r, the thing that you have to calculate, you have to find the term. The term is definitely fifth term, because 4 plus 1 fifth. And if you want to put the value of r here, so this will become r, 4 means 2 to the power 8, and this minus half whole to the power r means 4, isn't it? So this will, is it minus of whole to the 4 means it will turn into plus. So I need not to worry about the negative sign. Only thing is 2 to the power 8, and this is 2 to the power 4 at the denominator. When it will be adjusted, it will be adjusted as the cumulative power of 2, that is 4 minus 4, 8 minus 4, that is equal to 4. So this will be your answer. Now if in case there is a elaborated answer in the options given, then only you can elaborate. Otherwise this answer, if it is no option is being given, this much also will give you the full marks. So you need not to calculate further, but only if the option is given in digits, you have to expand it, this NCR, and then further you have to multiply this. This is all. Okay, so I move to the next problem number 19. It says if A and B are sums of odd and even terms respectively in the expansion of x plus a whole to the power n, then x plus a whole to the power n minus of x minus a whole to the power n. This is making some sound. A whole to the power a is equal to what? So you have to find this. So now what is the condition of the sum? A and B are the sums of odd and even terms respectively in the expansion list. So as you know, when I expand any binomial of power n, will get some odd and some even. So whatever will be the case, this is the accumulation of odd terms and even terms together. Okay. So this, if I add, if I say that x plus a is, if I expand it, c0 yes, x to the power n plus c1 x to the power n minus 1a plus c2 x to the power n minus 2 into a square by, and it will follow till cn x to the x will not be there, but before the term if I write n minus 1 x a to the power n minus 1 cn a to the power n. So now this has containing odd terms and even terms like that. So can it be say like that? There is always be odd and even alternative will come. So this is nothing. We can say this if I further one step, if I write, if I keep all the odd terms in one place plus dot 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 plus all the even terms in one place, so that we can write as per the condition all the odd terms, that means these terms is A, and all the even terms is B. So this can be represented as sum of A and B. So we can write directly without saying anything, this is nothing but the sum of odd terms and sum of even terms. So this is the condition of the sum. Now coming to this, this has to expand it. Now from there we can say, now one more step we have to do. What is that? X minus a. Now if I expand it, what I will get? c0 x to the power n, c1 x to the power n minus 1a plus c2. Alternately plus and minus will come, that we have seen already during study of our theory, and you don't know what is the thing, so you can write it minus 1 whole to the power n minus 1 c n minus 1 x to the power x and a to the power n minus 1. The next term will be minus 1 n c n and a to the power n minus a to the power n. So this way, so you can see the odd terms, if I keep aside, all the odd terms are coming positive. So c0 x to the power n plus c2 x to the power n minus 2a square plus dot dot dot, and all the even terms are coming as negative, because after that term this will be minus c3. So all the even terms, so you can take minus common and put all the even terms in one go. Okay, c3 x to the power n minus 2. So if I take minus common, so all will become positive, and like that. So this can be again, because all the even terms is equal to a and all the odd terms is equal to b. So this can be written as a minus b. Instead of writing in expanded form, alternative plus and minus, I can write as per the condition, because a is representing the odd terms of the expansion and even terms. So if I expand this will come all positive, but whereas if I expand this alternative. But even a is always the sum of the odd and b is always the sum of the even. So if I clubbed up all the odd terms and all the even terms in one bracket, so this I can write a minus b. Now as we know it, so I can write x minus a whole to the power n, this is equal to a minus b. Now come to this, where I have to understand what will be the result of this. This is n, no sorry, I have written wrong. This is the power of 2n. This is power of 2n. Okay, now as we know that x plus a is a plus b whole to the power, this whole to the power. Now one more step to make it further easy, I can write x plus a whole to the power n square. 2n is there, so I am putting n here, square out this same I am doing for this whole power of n square. Okay, now this is what is a plus b. As per the condition, this is a plus b whole to the whole square minus this is a minus b. Okay, whole square. So now you can elaborate. What do you know? A plus b whole square minus a minus b whole square is nothing but a into b. Okay, so now if option you can see that you will get one option is equal to this, so you can choose. But what I did, I have done from the without seeing the options. So this is always give you more confidence that if you do without seeing the options, because option you may try and there you may get confused. Okay, so I always say student to avoid seeing the options. You do yourself and then match the options. Sometimes it may not be possible. That time only you just refer the options. Okay. So the next is 20. It says the coefficient of x to the power minus 17 in the expansion of x to the power 4 minus 1 by x cube whole to the power 15 is what? Now this is not very different from the problem that I shown you last problem. So any power of x that if it is has to be equalized, the common rule is that you have to take the term equivalent to r plus 1th term of that series. That is the only one thing. Whatever be the power, the first and foremost, the rule is assume the term be r plus 1. So this is the only one rule you have to follow. Then once you put the r plus 1 term in the generic form, you have to equalize the power of x with the power of x given in the problem. That is the only criteria. Then you have to find the r value and you have to put. This is the only one process for any such problem, whether it is x without any without x, the term without x value, anything. So this is the only rule. So what do you know? R plus 1 term of any series is NCR, first term whole to the power n minus r, second term whole to the power r. This is the one. Now what we have to do, we have to separate out the constant. The constant is minus 1 because I will take out the minus also, not to confuse with the other part of, means I have to separate out x only. So x here it is 4 into 15, 60 minus 4r, and x3r will come as minus 3r here. So now this is equivalent to minus 17. So 60 minus 7r is equal to minus 17. So from there r is equal to 77 and r is equal to 11, you can find. Now once you have found the value of r, it is very easy. What is the coefficient that you have to find? So the coefficient will be equal to minus 1 whole to the power r means 11, 15 c 11. So minus 1 whole to the power odd means minus, so the coefficient will be this one. You need not to elaborate unless there is a specific reason is given, means option is given in other terms in numeric value. Then only you have to expand. Otherwise, this is your final answer. You will get the full marks for that. Okay. Now moving to the problem number 21. Let x plus 10 whole to the power 50 plus x minus 10 whole to the power 50. This series is given as a0 plus a1x plus a2x square plus dot 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 a 50 x to the power 50 for all a belongs to real number, then a2 by a0 is equal to what? You have to find. Now you can see the terms is not given as the known binomial coefficient form. This is given in something else. A0 could be anything. This is, we cannot say that this is equal to C0 because this being affected due to the term, there is another constant is given in the binomial. X could be any value, this is variable, but 10 has a definite value. So 10 is a numerical value. So this will affect the binomial coefficient, whatever it will come automatically when you will expand it. So there is a standard coefficient will come as a binomial coefficient that will affected by this 10. So if I see this, so what do you know, how you can get similarity with that one, x plus y equal to the power n plus x minus y equal to the power n, that I have expanded. So now when you expand this, what we will get? Twice of all the odd terms. So odd terms contains what? This is summation of, if I say any specific term r is equal to 0 to 50 will be the range because r starting from 0 and the coefficient is 50 cr will come, and the first term whole to the power 50 minus r and the second term whole to the power r. This will be the generic term. Okay. So now what you have to find? You have to find a2 by a0. Okay. So this is nothing but e r plus 1 on a term of that series. Okay. So now what is your a then? This is 2 into, if I put the summation side outside 0 to 50, 50 CR and 10 to the power R, and this along with x 50 minus R. So this will be your AR, isn't it? Because you see AR means R is equal to 0, A 0, and X, if I put, oh X is coming, oh this is being reversed again. So if it is reversed again, now I have to take one more step, because X I kept the first term, but here the series is already reversed. So whatever X will find, whatever X means, if putting R is equal to 0, you will get the last term. Okay, so now to get A0, what A0 where X is equal to 0 means X is not, so the whereas this value will be 50 minus R, that we can say. Instead of reversing this, I am assuming this is the term. Now you see, if I put R is equal to 0, you will get A50, and with that X you will get 50 minus 0, that is equal to 50, the last term. So instead of, I can do another way also. What I can do, I can reverse the series to keep R this S as a second term, because you can see what as per the rule of this, second term will get increased in power, whereas the first term will get reduced. So you can see the series is expanded like that, and if it is equal to this, then X is increasing, so X must be the second term. So either I can do like that, or and if we take minus common, the minus of 50 it is again plus, so no harm in writing in this way the series. Then if you expand it, you will get similar. So in that case, if I expand, I can take this is AR. But if I don't do that, if I keep the same it is, I can assume this to be A 50 minus R, this term, because this will giving, if I put R is equal to 0, I am getting A 50, and that also matches when I equalize the R power. Okay, so if it is so, now to get A2, when I will get A2, so that means I am putting R is equal to 48, then only I will get 50. So A2 will be how much? 2 into 50C 48, 10 to the power 48, isn't it? And what else I have to know? A0. So if I want to get A0, so that I will get when, if I put R is equal to 50. So if I put R is equal to 50, this term will become 50C 50, 10 to the power 50. Understood? Now if you see, if it is very complicated, you can turn this round and you will automatically get accordingly the thing. What you will get? You will get 2 to the power, this will be the summation of R is equal to 0 to 50 there, and your term will be 50CR 10 to the power 50 minus R into X to the power R. So now if I put R is equal to 0 here, I will get the first term, and then if you equalize the A0, here you can get A0 is equal to 2 into 50C 0, R is equal to putting, and 10 to the power 50. Now you see, you will get the same thing here, because 50C 50 and 50C 0 are of equal terms. So if you move like that, you will get the coefficient which is companion, not companion, equal, sorry, 2, this 2 into 50C, if you have to put 2 here, 50C2, 10 to the power 50 minus 2 is 48. Now see, in power you are getting same as it is in both the case, but only thing, the binomial coefficient is coming the other one, from the other end. because I am turning this series. So this also can be done. This also is true. Now once I got the term, my task is to find the ratio. So if I want to get A2 by A0, what I am to get? A2 is 2 into 50C48 into 10 to the power 48, and this is equal to 2 into 50C50 into 10 to the power 15. Okay, this also done. Now to calculate, 2 will be cancelled out. 50C50 is equal to 1 here, and there it is 50 into 49. Below it will come 2. There it will come 1, and this will be adjusted into 10 square. Okay, so 50 into 49, ultimately this will be equal to 2 into 100, 52, that means 49 by 4, 12.1. It is given in decimal, so I am just calculating. 4 12s are 48, 1 will remain, 4 2 8, 4 4 and 4, 4 2 8 2 0 4 5, isn't it? 4 2 8 2 0 4 5. So 12.25 will be the answer. Okay, understood? So other way around, if you turn it, also you will get the same answer. Okay, so I'll end up here. I will start from number 22 in the next video and move onwards. I will be keeping this number here so that I should not forget. Okay, thank you for now.